Okay, so this is module 12 wireless LAN concepts. We're going to go through the concepts of wireless. Yeah. So the areas that you're going to look at: introduction to wireless, components of wireless LAN, wireless LAN operations, then couple operation, then channel management, wireless threats, and with how to secure uh, wireless. So introduction to wireless. Wireless LAN is the type of wireless network that is commonly used in homes, office, and then campus environment. Because right now it's a trending network. Can you sure that you guys you have MiFi and blah blah wherever you are? So it's not a must that you have to go to uh, location where we have the physical network infrastructure to have internet access. No, we have those network infrastructure that are mobile. Wireless infrastructure adapt to rapidly changing needs and technologies. Like right now, if I'm to give you exact network type of network that I'm using my smartphone, meaning if anyone calls, then I will go off. So I'm tethering. It's also one way as you're going to do. Types of wireless network, we have what we call wireless PAN, the MiFi that you have there with you. And of course, it has to work within the room. If you're outside the room, it won't. If you have it in your pocket, if it's in the pocket, you must be having the phone. We have what we call wireless LAN, medium-sized network up to 300 feet. That if you have that, you can even move around your compound as you're enjoying. But MiFi it might not allow you to do so. Then we have what you call wireless MAN, large geographical areas such as city district, wireless that can cover a town, a city. When it comes to that, it has a specific licensed frequencies, of course, frequencies. Then we have wireless wide area network, extensive geographic area for national or global communication. Still, it uses specific licensed frequency. This it's there that actually can cover cities, maybe from let's say Kampala, where Kampala go to the other side of Nambode, Mukono, that it's one network or something like that. But we haven't reached that level. We're still struggling. Because now you're going to ask me where in our country is it? Do we have any type of that network? No, it's not there. We're still struggling. Wireless technologies, we have Bluetooth. You all know Bluetooth. It's one of wireless PAN standard used for device pairing up to 300 feet or 100 meter in distance. When it comes to Bluetooth, we don't need obstacles in between. We have WiMAX, worldwide interoperability for microwave, worldwide interoperability for microwave access, alternative broadband, wired internet connection. It's up to 30 miles or 50 kilometers, covers cities from Kampala, maybe Nambode, Wakiso, something like that. Yeah. So even when you look at the infrastructure, see this, it is actually far in space, but the signals are not interfered by any other devices or any other gadgets. And then still under wireless technology, we have cellular broadband, as you can see, the cell towers carry both voice and then data used by phones, automobile, tablets, exactly what you're using right now. So my network that I'm using, it's actually through the cell towers. Then we have satellite broadband uses directional satellite dish aligned with satellite in geostationary orbit, needs clear line of sight, typically used in rural location where cables and digital subscriber line are unavailable. So when you look at the infrastructure here, we don't need the cables and blah blah. So you guys, you've ever heard about the satellite phones, satellite phones. The satellite phones, actually, we don't have that infrastructure around here. It is somewhere. That's the reason why they always say that satellite phones, they can't be tracked. They can be tracked, but only that that technology is not based here in Africa, blah blah. Meaning that if it is to be used, if someone has a satellite phone here in Uganda and is to make a call, then all the signals, they have to go broadcast. So the satellite broadband uses directional satellite dish aligned with satellite in geostationary orbit. So it needs clear line of sight, typically used in rural locations where we don't expect any network infrastructure. For it, it will be actually the best option. Within here, our country is not all that common, but if you go to our neighboring countries like Congo, I think even in Sudan, South Sudan there, LS, and okay, those countries that are too big to the extent that those areas that are too remote, no roads, not anything like anything like the infrastructure, road infrastructure, the power, blah blah, all that. The satellite network, it works better, or it's the solution in such places. We have what you call the standards, of wireless. So the standards, they are here, as you can see. This is the parent, the original, and then standards, the way they have been actually changing or coming to the market. These are innovations. We have A, there is B, G, N, A, C, A, X. And then with the frequency, So the frequency, we have 2, we have 5. If not 5, it's 2.4, sorry. There are those that supports both, and then there are those that supports one of the two. And then these are the description in speed. In speed, what's the difference between this? Because when you look at this, this one here, and then this, the frequency is 2.4. So what's the difference between the two? Now you come to the description. So this one here, the rate, the speed, it's 2 MBs, and then when it comes to this B, it is 11 MB. So this one here, it is a bit faster compared to this one here. And then even the distance and all that. So in your free time, you will have to read through. So all wireless devices operate in the range of electromagnetic spectrum. Wireless devices. So we have those radio waves, and the radio waves that are used by different devices. Actually, when you look at this, the guys, as you can see, that there are the radios. We have the same tower. We have television, a microwave. Then we have those are under radio wave. We have infrared, the dishes, and then as you can see. Then after that, we have ultraviolet waves to deal with solar. To deal with solars. Then we have X-rays, we have gamma rays. There are those waves that are dangerous to us. There are those that are useful. There are those that they're used in different, depending on how strong they are. How strong they are. So mainly, in our wireless, we have 2.4 and then 5. So with 5, as you can see, the standard that uses 5, they are here. We have A, N, AC, AX. Then the one that supports 2.4, still we have B, G, N, then AX. So there are those that supports both. So you'll use the other table of standards to get to know that. So here we have wireless standards organization. Wireless standard organization, where we have International Telecommunication Unit, Institute of Electrical and Electronics Engineering, then Wi-Fi Alliance. So please read through what they stand for and what's their purpose. What's their purpose? So here we have wireless components. Wireless components. There is a video where the video will cover the following. These are components, wireless components. We expect the antennas. You guys, you know the antennas. Then wireless router. Then we have internet port. The wireless router, it has to have an internet port. The internet port, for example, if this is our wireless, it has to have an antenna. Okay, some they do have one, others two, others they do not have. So it must have one port for internet, and then other ports for connecting the end devices onto this device. So we have antennas here, wireless router, it's the order of this one here, internet port, this one here. In case, let's say you want this device to distribute internet, you have to feed it with cable with internet, and that port, it has to be the internet port. Then we have wireless access point, which is the same. Then autonomous and then controller-based access control list. Sorry, not list, but point. There are those access control lists. Sorry, not access. There are those access points that are controlled. If you want to do the settings to alter it, you just go to the controller. Whatever that you feed that controller, it is distributed onto all the access points. So the antenna, look at this. Now with this, we have wireless network interface card. Wireless network interface card. So it's in form of USB drive. So if in case, let's say your device has issues with wireless, you can actually go buy this and get an external, the external one. So it has the antennas, you can see, for receiving the signals. So the antennas that we're actually talking about, as you can see, they're here. These are 3. We have internet port. When you look at these are almost like 3. These are for connecting end device to this device, but this one here is for internet. That if you want this device to distribute internet, get a cable with internet and then connect it to this port. So wireless router serves as the following: access point, which is the entire of this. That is our wireless router. It's a wireless router, so it serves as an access point. It serves as a switch. So these ports are serving as the switch, and then the router. So being that this is a separate, you have a question? So now here, to be a router, because look at this, that a router, it interconnects network. We expect network B to be connected to network A to be connected to network B by this wireless device. So here, this network A, let's say it's connected to internet port, and then this in the switch. The switch. So this one here, it qualifies this device to be the router because it is interconnecting to networks So this is an access point because the access points are of different form factor. Form factor. You guys, you've ever looked at, interacted with the access points, but of different designs. So here is one. So tomorrow you will be dealing with a different one. When time comes, I will actually show you what I always use. So they can't be of the same design. So the access point categories, we have what you call autonomous AP and then controller based. Autonomous, these are standalone. Like the way you see this, so that you have your network and then you get an access point, add it on your network to interconnect or to connect the devices or those personal devices where you don't need the cables. See? Then we have the controller based. The controller based, when you look at this, we have wireless LAN, wireless LAN controller here, that if you want to control this, you do the changes on this controller. So this, once you have this design, you can add as many access points, see? And they are controlled by this wireless LAN controller here. So that is the controller-based AP. So types of external antennas, the antennas. So there are different types. We have what we call omnidirectional, which is this. We have directional, which is this. As you can see, it is pointing in a specific direction. Then we have multiple input, multiple output, which is MIMO. Multiple input, multiple output. That there are those antennas for inputting, receiving, and then there are those antennas for sending. Wireless access, wireless LAN operations. So this is a video that will cover the following: infrastructure mode, ad hoc, infrastructure mode, then ad hoc. Tethering, I talked about tethering. Then we have basic service set, extended service set, frame structure, carrier sensor, the method that is used to avoid collisions, the collision on the wireless network, wireless client AP association, and then the passive and active delivery mode. So all that. The ad hoc, this is when you connect two devices. Using, for example, using Bluetooth. There you're using ad hoc, peer-to-peer. It's this machine with this machine, period. You cannot connect the third one. We have infrastructure mode. When it comes to infrastructure mode, you need an intermediary in between here. So once you have intermediary in between, then it means that you can connect as many devices as you want. Then tethering, all you guys, you're familiar with tethering, and it's the method that I'm using. I have my phone in between internet and my computer here. So if in case one calls, then automatically this link is going to be blocked temporarily, and then I answer the calls and then reconnect again. But in terms of speed, it's better than hotspot, even the Wi-Fi, only that it connects one device at a time. When it comes to infrastructure mode, it defines two topology blocks where we have the basic service set and then extended service set. That once you have intermediary device, then you have to set the name to use. That every time that device is trying to connect, or if you to locate the access point, you have to locate it by name. So it uses a single AP to interconnect all associated wireless devices. So once you have your PC somewhere, you just locate the service set, the name of the access list, the name of access list. So that is it. Now this one here, it's just single to locate this. Then when it comes to extended service set, it's a union of two or more basic service set interconnected by wired distributed system. So with this one here, it has to work with the controller, because this one here, it is autonomous. It is autonomous, standalone. This, as you can see, it's standalone. But when it comes to this, now we have access, so many access control lists, and then you can actually use one basic service set onto all those access control lists. So clients in each basic service set can communicate through extended service set. Extended service. So this is basic service set identifier, even this one here, but they can be controlled. As you can see, this is extended service area on this. That these two, they are under extended service set, and you can have a controller to control them. So this is the frame format, which is similar to Ethernet, except that it contains more fields. It contains fields, more fields. So we have frame controller, then the duration, it has to have the duration, how long should it use the media, then the addresses, the sequence, and then the continuation of the address, because there are always more than one address. The address for the data from source to destination, and then the address just trying to, which device is say on the network trying to request for the token, or the requesting for permission to use the device. So there is the addresses for identifying the devices in the communication, and then even the requests from the device to check whether the access point is free, so that the devices can use them, as you're going to see on this slide. So wireless LANs are half duplex, and client cannot hear while it is sending, making it impossible to detect collision. Wireless LAN use carrier sense multiple access with collision avoidance. So as the device is trying to communicate wirelessly, there is always what you call collision avoidance mechanism to determine how and when to send data. So a wireless client does the following. So the client, it listens first to the channel to see if it's idle. So there it has to be communicating with the address. No other traffic current so that it knows that to get to know that if there is no any other traffic currently on the channel. So after that, then the client, it's going to send what the message called ready to send message to the AP to request the dedicated access to the network, and then receives a clear. So the client, once it sends it to access point, then the access point is going to reply with a clear to send message from AP granting access to send. And then it can actually, the client can actually also wait a random amount of time before restarting the process if the if no clear to send message is received. So if it fails to receive clear to send from the AP, then it has to wait a random amount of time before restarting the process, and then still it can transmit the data. That is, if the channel is idle, and then still it can acknowledge all transmission if wireless client does not receive any acknowledgement. It assumes that collision occurred and then restarts the process. So those are those are the roles that are done by the client in the process of actually checking to before it starts sending frames or packets through the access point. So we have what you call the wireless client and AP association. So when you look at this, you have a client and then the AP. There are three steps. That this PC it's going to discover the AP, and then after that, this client, of course, if there is, let's assume that the AP is CCNA, then the client has to log in to that AP. That is the reason why you're seeing authenticate. So if you provide the collect password, then it will be allowed and then associated. Associated. So the client discovers AP, then authenticate with AP by providing the passwords. Once the passwords are collected, then the two are associated. So to achieve successful association, a wireless client and AP must agree on specific parameters. So you have, it's a must, the SSID, Service Set Identifier, that you have to locate. If the AP is CCNA, yes, you're able to see it. And then you provide the password. And then the network mode standard in use, the standard in use. Of course, those ones, they will always be there within, and then security mode, the mode, and then the channel setting. The channel setting here, it can either be 2.4 or 5, or most of the time it is set to auto, and the auto is the best. The security mode, still you are going to look at the modes. Then the network mode, the standards are always within the technology, the device used. Then the password. So most of the time it's this, you locate this and provide the password. So still under wireless operation, we have what you call passive and then active discover mode. With passive, AP openly advertises its service by periodically sending broadcast beacon frame containing service set identifier, supported standards, and then the security setting. So with this passive, you'll be able to see the wireless, the access point that it's CCNA. So meaning that the AP, it keeps on broadcasting all that information, the supported standard, the security, all that. When it comes to active mode, it's you to know all the information that is broadcasted here, you must be knowing it. Meaning that intruders, they won't be able to tell, because you won't be able to discover the name by checking under your wireless, the wireless devices that are discovered by your device. You won't see it there. So you must be knowing that there is a wireless network called CCNA, and you create it on your network. I think that one we shall actually do it practically. Yeah, practically.